Hello, welcome, my students. We are going to continue with our series on hydrometer. Last time we saw that we derived the relative density of a liquid from the hydrometer, and we saw that for the hydrometer, the density of the liquid, I'm using symbols because we have defined them already in our previous lessons. So LW is the length of the submerged part of the hydrometer in water. The L1 is length of the submerged part of the hydrometer in liquid. Rho L is the density of the liquid and rho L is the density of water. Then we also said that RD of a liquid is LW LL. We have seen this equation. We also talked about the fact that because the hydrometer works on the law of flotation, all the flotation equations hold. Good. So now let's use this idea to solve this question. A uniform cylindrical hydrometer of mass 70 kilograms and cross-sectional area 3.2 meters squared flows in engine oil. If 32 meters of its length is submerged, find the relative density of the engine oil. And we are supposed to take the density of water as 1000 kilogram per cubic meter. Right, so pause the video and write down the question. I'm going to solve it systematically. So this is our solution. I want to divide the board. Let me shift here. Yeah. So question 1. We are doing question 1. What are we given? We are given the mass of the hydrometer as 70 kilograms. We are also given the cross-sectional area of the hydrometer as 3.2 meters squared. We are given the length of the submerged part of the hydrometer in engine oil. So I can call that one L because it's L, let me call it LO. Okay, length of the submerged part. Or better still, sorry. So LO, or if you prefer the LS. In engine oil is giving us 32 meters. And we are supposed, the question wants us to find the relative density of engine oil. So this is what we are looking for. So how do we find relative density of engine oil? We know that relative density of engine oil becomes the density of engine oil, right, over the density of water. Okay, so that is that. And we have been given, the question gave us density of water as 1000 kilogram per cubic meter, or we can write it this way. So what is our focus? Let me write this equation down. Let me call this equation star. I prefer using star a lot. So down. What can we do here? Our focus is to get, because we were given the density of water, that is why I quoted this formula. I didn't use the length LW over LS, L oil. I didn't use that one because we don't have much information about that. So our focus is that we want to find the density of engine oil. And how do we find the density of engine oil? Let us find it from the upthrust. Okay. So what do? We know that according to the law of flotation, okay, we know that the weight of the hydrometer should be equal to weight of displaced oil. Okay, so what do? This is the same as mass of the, so if I find the weight of the hydrometer, I will get the same as, because I didn't know mass of the displaced oil, let me find the weight of the hydrometer. And the weight of the hydrometer can be calculated as the mass of the hydrometer times G. Okay? Better still, times G. So what do we get? That is a 70 times 10. And this becomes 700 newtons. So what does it mean? This implies that upthrust is also equal to what? 700 newtons. And how do we code this? From the Archimedes principle. Archimedes principle is saying that the weight of the displaced liquid is the same as upthrust. So we have gotten the weight of the hydrometer to be 700, which is equal to the weight of the weight of the hydrometer is 700 newtons, which is the same as the weight of the displaced engine oil. So the weight of the displaced engine oil is the same as the upthrust, according to the Archimedes principle. Now let us continue. How do we calculate upthrust? But upthrust can be calculated as density of engine oil times volume of displaced engine oil, okay, times G, right? Displaced oil, okay, times G. So here we know the cross-sectional area and we know the length of the submerged part in the oil. So our work is almost done. Look at this information we have here. Okay. We are given this and this. So I won't use this formula. I will use this formula. Density of engine oil times what? Cross-sectional area of the hydrometer times LS of the oil. That is the length of the submerged part in the oil, right? Times G, right? So this is 700. 700. This will help us get the density raw oil. Let me use symbol for that to make my calculation simple for me. And the cross-sectional area is 3.2. And the length of the submerged part is 32, according to the question. And we know G to be 10. Are we not done? So eventually, when we want to find the density of the oil, somebody may, okay. Don't get confused with these ones I have written. You can omit it. This one too. I'm just using rho O for density of oil so that it will make my working simple for me. You can repeat it throughout, okay? So this is 700 over 3.2 times 32 times 10. You can choose to work them before you divide. It is mathematics, so you are not restricted to a particular step. And when we work this one out with the calculator, we are going to get 0.684. Density is in kilogram per cubic meters. So that becomes the density of the engine oil. So density of the engine oil is now at 0.684, sorry, 84 kilogram per cubic meters. Now I'm left with my last step. Therefore, we have already quoted the formula from equation star. What is equation star? We stated equation star that the relative density is the density of the engine oil or density of water. So equation star, relative density of engine oil is equal to density of the engine oil we found to be this, right? 0.684 over density of water, which is 1000. So kilogram per cubic meter, kilogram per cubic meter. So they will divide and you get 1. So we eventually get, according to our calculator, 84 times 10 exponent -4. So it is unitless. That answers our question. Right, so let us end on that question here. And if you have any question on what we have done, kindly send it in the comment section. Right, hope to see you again in the next video. The next lesson, I'm going to solve another interesting question for you. Stay connected to our channel, subscribe, and enjoy more videos. Goodbye.